Welcome back everyone to Data Science for Everyone. Today we're going to be going over a linear regression example with e-commerce data. So first off, let's going to talk about at least the data set. Let's do our basic imports. So import pandas as PD, import numpy as np, import seaborn as SNS, import matplot libpyplot as plt, and let's do matplot lib inline and run that. Now, first off, let's actually import the data. So let's just call this customers for now. P.read CSV, and then this is I don't remember what I called it in here. So let me take a look real quick at what I decided to label the data. E-commerce customers.csv. And let's read that in, and let's take a look at what the actual data looks like. Head, and then let's also do customers.info as well. So we see here that a majority of them are floats with 3 string types. Now let's go over a little bit. So this is just basic customer info. Again, it is faked data, okay, using the faker package. So for those of you that don't know that, it's just faker. And so let's actually do a little bit of the descriptive statistics as well. And we'll talk about this as we go along. All right, so first let's look at customers.describe. Look at the descriptive statistics here. And we see here that we have, so looking at the descriptive statistics, everything seems to be all hunky-dory. And we've also looked at all of our data. So we have 500 rows here. We have email address, whether they have an avatar or not. And again, this is just going to be some color scheme here. Time that they spend on the app, time they spend on the website, how long they've had their membership, and the amount of money that they've spent, as long as their average session length. So let's take a look and do a basic exploratory data analysis. So let's do just EDA here, and let's see here. So we want to do an SNS.joint plot, and let's see about where X is equal to our time on our website, and we want Y to be the yearly amount spent. So for example, here the whole purpose of this would be to see if our customers are spending money the longer they're on the website. Now the joint plot is a very useful tool on this. We see the distribution of both of these curves here. Now I didn't expect a whole lot because again this data is predominantly randomly generated, so that's why we're getting this shotgun blast. They're both normal distributions. But we can also take a look and see, for example, is we'll try maybe this with what did I want to look at here? Maybe time on the app. And let's do time on app, and we want to compare this to yearly amount spent. Okay, now here we actually see, let me clean this up. So this here, we see that there is a positive trend here. They are both normally distributed. So then definitely the yearly amount of time spent definitely has a positive correlation, potentially, with the time on the app. Now, let's also look at potentially maybe comparing this. Again, sometimes if there's a lot of observations here, you don't really see much of a pattern. And so we'd want to maybe try using this with a hex plot. So if we change this up, we can keep this little bit here, and let's change this up to kind is hex. And we run this, this is going to help bin everything a little bit together. Now we can actually see it's a little bit more of a heat map in itself, where we have these nice little dense plots and these denser spots in here. So then these are the more common areas where we have data. Again, it is still normally distributed. And then finally, let's also run a pair plot in here to see all of the variables together. And just a reminder, try to not run this that often, particularly if you have a lot of data. But this, it shouldn't be too bad. It may take it here maybe a minute to run this, since it is only 500 observations. And so again, we see here there is definitely, basically all of these look like a nice shotgun blast of data, except for here, this is again the length of time of the membership with the yearly amount of time spent. It definitely has a positive correlation. And again, we see that same with time on the app as well. It does have a little bit of that, you can see here it's squished on the sides and it's elongated a little bit. So it does have a positive correlation. Now, based off this plot, okay, what can we actually say about this? Well, that's again, maybe we want to maybe create a linear model. Again, this is very linear in its nature, okay? You don't see any, there's not a lot of variation anywhere in it. It doesn't have this undulating pattern, particularly since this does have, potentially could have a time series component to it. It doesn't have any seasonality to it. And it doesn't have any necessarily, like if we look at all of these, it looks like it's just one large clump. So then there's probably, we may not want to look at any clustering or classification of any sort as well. So let's try and do then just a basic linear model. We can do this in a couple different ways. We can use the LM plot and do something like, again, we want the length of membership, and Y, we want it to be the yearly amount spent here, and data is our customers. And we run this and we can see that this definitely fits the model. It does a decent job. It's not perfect by any means, but again, this is probably the best that we would wind up doing. And again, just using kind of a basic linear regression, binomial regression as well. So now let's maybe turn this into a little bit more sophisticated model. Again, this is just a binomial, or not binomial, but a univariate test. And so let's go about using, let's split this up into our Y. So we want customers, and we want, we want what do we want to grab here? Yearly amount spent. So again, we want to predict how much our customers are spending on our platform per year, again, based on some variables. And so what do we actually want here? When we looked at everything, we had a couple interesting options. So one that we're going to use is probably average session length. We want time on the app. And again, we want time on the website. And we also want something like the length of membership. So again, we're putting this in, I'm just putting this into this X and Y because this is something that we're relatively comfortable with. I like to keep everything very normalized in how we reference everything. So now from scikit-learn dot model selection, we want to do the train test split. And so I'm going to do the little bit of a cheat here, and I want to go down, grab our template, paste this in, and we're going to run, and we're putting this into our X train, our Y train, and let's go on and just go straight into diving into our model right now. So let me put up a little bit of a note here. Train linear regression model. So first with this, we have to, from sklearn dot linear model, import linear regression. We need to instantiate the model. So let's do linear regression. We're not going to do anything else on that. And then we need to run our train tests, or we've already run our train test split. So we run our fit on our X train and our Y train. Then we need to go through and look at our coefficients. And so let's look at it in let's just actually just do a basic print on this. We want to do lm.coef. Let's take a look at them. Okay, so we have here this, and so let's make it into a nice data frame here. So we have our we want our coefficient, our coefficients, and then the data itself. So let's do lm.coef. I think that should work for us. Oh, why does that not work for us? All right, let's do and I want to change the columns, and we want this to be coef. All right, so here we actually see our coefficients, and we also want to do we want to actually keep that in there? Yeah, let's do set our index, and that's going to be our x.columns. So now we actually see what we have here. So the most important thing to have here is the length of their membership. Again, the longer someone has spent, again, this is, right now we're not actually running anything heavy on this, but we should at least be able to kind of talk it through. But this is what we're assuming, is that length of membership is going to cause people to spend more money. And again, this is just fake data. So again, don't take it with a grain of salt. Let's make sure and do our predictions as well. Predict, and we're doing this on X test. Run this, and then let's do PLT scatter, and we want Y test with our predictions. And let's do PLT X label Y test, and then let's do PLT.Y label and predicted Y. Sometimes people will call this Y hat. So notice here, it's actually pretty decent. Okay, everything's nicely clustered around a 45-degree angle. And so let's go on and actually do a bit of model evaluation, and then we'll do our conclusion once we plot our residuals. So the next portion that we want to work on is model evaluation. So our model evaluation, let's do from sklearn, import metrics. And so this is going to be the same as what we've done in the past. So let's do print MAE, and we want metrics. Why is that not popping up? There we go. Metrics dot mean absolute error. We want our Y test and our predictions. Then we want to print out our MSE metrics, and then we want here our mean squared error, and we want this on our y hat, or y test, sorry, with our predictions, or our y hat. And then we're also going to print out and do the RMSE. And here we're going to do mp.square root. And then here inside here we're going to do metrics dot mean squared error. And we want y test with our predictions. And then we can also do print here, and we want r squared. And here we would do metrics dot r2 score, and then y test predictions. And run that, and here we see that this actually this is actually doing quite a lot of good right now, particularly if we just look at our r squared. It's giving us a around a 98% accuracy, depending. Again, it's a very good fit. Now let's double check and look at our residuals. Let's do displot here, and we want to do the difference, so y test minus our predictions. And we're going to set our bins. As usual, we're going to do 50. And so we see it's relatively, it's definitely not normally distributed by any means here. We have some spikes here and there, but it's really not terrible in this instance. So let's move on and let's do our final conclusions to this. And so let's say our coef is going to be pd.dataframe. We want our coefficients, and with our columns, I'm just going to do it in a little bit easier fashion here, and do coef dot columns is actually going to be coefficient, and then coef. So here we see here that, again, this is the same as what we had before. It's nice and clean. So how are we actually wanting to interpret these results? So let me pull up a little bit of a text box here, and let's call this a result interpretation. So again, ceteris paribus, here a 1 unit increase in, and I'm going to make a bit of a template here real quick. Something is associated with n, and again, this is either going to be an increase or a decrease of, again, some number here, and it would be actually, since we're trying to predict a numerical, specifically, it's going to be total dollars spent. And you know what? I can actually delete that, and I can delete that and put this at the end here. All right, so let me copy this, and so I have the example in here. So first off, let's look at our average session. Length is associated with a 25.7 increase. Oh, an increase of, sorry. Let me do this. I want an increase of 25.7 total dollars spent. And then we can do the same thing with the others as well. So our time on app is associated with an increase of $38.57. You know, I'm gonna clean that up to a 0 there. Total dollars spent, and then we can also do the same thing again when we're talking about the time on the website as well. It is associated with an increase again. And again, we would say it's a decrease whenever we have a negative coefficient of 0.62, let's call it 63, total dollars spent. And then let's go in and say for the length of membership. So it's going to be associated with an increase of a total of 61.71 dollars spent. So overall, this was a real quick way to take a look at running a basic linear regression model. Thank you very much, guys. If you like this, please make sure and subscribe and comment down below. I'll see you next time. Bye-bye.